Hello friends, today we'll be talking about the introductions to 3D visualization and 3D GIS. So we'll see a few applications of 3D visualizations and the upcoming 3D GIS technologies and how it can be used in special cases. So this is introductory class, so I'll be just talking about the different components of 3D GIS and 3D visualizations and how we can plug different components of 3D GIS to achieve a specific objective. So let's talk about the earlier 3D visualizations, how people used to do. So this is just an example where a 2D map used to be generated, and this is actually a paper map where the height is being measured with the different color tables values. So we are being given a set of color tables and then that can be used to do correlations between these tables and correspondingly the geographical data sets which is being represented in a 2D maps to find out the height at a particular locations. Later on, we had extended that particular technologies from 2D papers maps to the 3D GIS format. So earlier, the first attempt which is being made in a computer-based 3D visualization is called 2.5D methods. This was just an extension of the different raster dataset which we are going to have from different sources, and then that raster dataset's attributes gets extruded by a specific values. So that value basically gives the kind of variations of your area in a specific locations. For example, in this case which we are seeing it over here, that the area which is being highlighted in a blue color is actually is a lower area, and the area which is at the brown color is showing you the higher rich areas. This was later extended to using a DEM wrapping. So people started getting the different DEM data sets that used to get wrapped with different WMS layers to give a realistic visualizations tool. So that was actually a beginning of the 3D visualizations data sets in a computer domain. Later on, people also started to give true 3D representations of the data sets. So in the earlier two cases, what we see is that the 3D data set is being put into a 2D display plane, and then what we do is we do an interpretation. So either maybe a color table based, as we have seen in the first case, or it may be in a form of different tubs which is being generated and then finally is being displayed in a 2D display systems. In 2.75DD or analogous stereo, basically it provided an interactions of the visualizations, especially the 3D visualizations to real user. So under this case, what happens is that any specific users, if he or she is going to have red and blue screen spectroscope, so he can see that there is a 3D exaggeration of the different areas. So all those areas where we are seeing is red and green color tint variations can be seen as a higher exaggerated areas, and wherever we are not seeing any color exaggeration or the color area which is being shown in a gray color will be seen as a lower areas. So this was just an extension where the 3D visualization has been extended from screen-based visualizations to the human perceptions. Later on, people started using that particular technologies or the extension of attribute-based visualizations for different attribute data visualizations. For example, in this case that we are having a different polygons. Each polygons is having a specific attributes, and the attributes use to be exaggerated by a specific values. So whatever values was there in attribute tables, that used to be taken into an account to give you a 3D exaggerations of the area. So this kind of visualization is actually useful for showing an importance of how the other areas or different polygons are actually interrelated with each others in terms of bringing the 3D perspective into and data assimilations cases. Later on, the DSM based digital surface model used to be created, and over here each of the data points actually will have an x and y and z coordinate, and these x y z coordinate in tandem is used to get created a digital surface model. So this is actually the beginning where the bare earth models people started using it, and it started is that particular starting of this visualization has started. So under that circumstances, what used to happen is that the DEM layer used to be there at the bottom of visualization, so which is actually a core, and on the top of that different analytical result used to be uh, wrapped on. So this is visualizations where the actual DEM data set used to be wrapped on with the corresponding analytical data sets. Nowadays, the 3D GIS has actually extended into a different domains, and there actually we are seeing a lot of applications which is coming in. All these are actually possible due to the recent advancement in the hardware, where the end users computing hardware is actually having a very good graphics capabilities, and there is also an extension of different web-based frameworks like WebGL or HTML5, which actually allows direct interaction of the hardware capabilities, which can be exploited for different 3D visualization. So due to that advancement in the hardware technologies, software has started using those capabilities, and we see a variety of applications. For example, in the architecture domain, the earlier CAD drawing, whatever was available, this people started converting them into a 3D models, which again was being distributed in a different GIS ready format, and that can be used for visualizations. Under the environmental modeling, people started using 3D GIS to do simulations in a 3D environment. Archaeological studies are the another area where the restoration processes is being aided with the help of current 3D GIS technologies, especially the laser-based techniques and the photogrammetric tools is being used in getting a detailed level of archaeological recently. We'll see a few of the examples in a later part of this video. We are also have seen that under the geological analysis, specifically the data set which is being collected in a different bore wells, especially in the petroleum industries, that can be overlaid in a different format to find out a prospective volume estimations of the gas or a petroleum product. So that is the area where the 3D visualization is being widely used. There's also an hydrographic surveying, so it gives the distribution of different data sets in form of hydrographic surveying. Navigations, already we are seeing a few applications, specifically if you use the Google Map based techniques, which actually shows you the different navigation parameters. It also shows you the available 3D building around it, so that kind of applications are already underway. The utility mapping or the underwater supply, water supply, sewerage lines are actually another area. So what we see over here is the underground water supply navigations are actually an extension of different 3D urban mapping techniques. The 3D GIS also is being used in a different ecological studies to find out the 3D distributions of different species. For example, few of the species which is available in India may not have a same height as it may be in other part of the world. So that kind of visualizations, the distributions, linking back with the 3D domain of these data sets, where the 3D GIS can be used to see the differences. So this actually, all these applications basically allows the end users to find out what are the different 3D parameters which can affect a specific conditions. That actually is that basically allows end users to find out different, or basically this it allows the users to do a visualizations of models in actual 3D environment, how it will look like, and this helps in the understanding of the environment in a better way compared to 2D visualization based techniques. So let's take an example of virtual 3D city models. What we are seeing over here is that we are having a base layer, the base 3D data set which is being created. So it's actually consists of different urban features. Over here we are seeing a few buildings which is available to us, along with that different photorealistic layers which is available, and that is being shown over here. Now these base layers can be used with different texturing parameters to have a landscape visualization, so as we can see over here, or it can also be used to integrate the different modeling tools, so which can be used in a different disaster management or the flood modeling techniques. So under that we are seeing that in the blue color, basically what we are seeing over here is actually an extension of the flood waters in a different areas in a particular cities. There's also a possibility whenever there is a data set which is available in a temporal domains to find out a different change detection. So this basically gives an idea of in a particular geographical domain how the different resources is being put in to make changes possible. So this is actually showing the area where the new development has been planned in a particular city, specifically the New York. The 3D GIS techniques, again, if you use the 3D GIS layers and we link it with the future planning. So in case, like, suppose we want to have a specific zones for economical activities, and that area needs to be planned in. So correspondingly, we need to find out where we can build those specific zones or industrial areas, what are the connectivities, and what is the expected outcome. So this actually helps in an economical modeling of a specific city. So that can be used uh, in such scenarios. The 3D GIS is quite helpful, because nowadays we are seeing a lot of cities is actually having a vertical expansion. So this allows the capabilities to link that vertical expansion scenarios into our 3D planning methodologies. There's also an energy efficiency. This is another applications where we can see that how the power distribution is being used in a different cases, or we can also see that if the power distribution can be linked back to existing solar potential of that area. So in that case we can improve the energy efficiency. So these are only the few applications where we see that the different 3D GIS layers are there, which can be used in a variety of cases. So those were actually the cases where we saw that how the 3D data set can be used for visualizations different activities. Now we'll see that whenever we are having a 3 data set, so what kind of 3D GIS query which we can do it. So we'll just see a few of the interactive query which is possible. For example, if you want to query a specific structure or a building, we just need to do a selection. So over here we are seeing a green color building. The corresponding detail attribute of that building is shown over here. So this allows attribute based query of specific objects. So in a spatial domain, if you want to find out the details of different buildings which is being distributed in a city, we can just have a link, click on that, and we can get the different attribute informations. We can also use these different attributes to do a filtering. For example, over here there's a large data set which is available on the top. So we would only like to see all the buildings which is having a height of less than 50 meters. So that can be seen over here. And again, those can be classified in different groups to have a visualization. This actually gives the distributions of the spatial distribution of the different building at different heights. So this can be again used for the redevelopment plan, or it can also be used to find out how the different areas within a city or a zone is actually having a spatial distribution. So that can again be used in a spatial distribution modeling and other extension of the datasets can be used. Now we are seeing also the same case to do a similarly case on the same data sets, but we want to have the particular classifications. So over here we are seeing around 8 different classes has been created based on the height distribution. So this gives that how the different height is being the different buildings has been developed. So the building on the left side are actually is having a lower high-rise buildings, where on the right side, which we are seeing number of buildings which is quite large. So this can also give an idea how the city might have evolved in a particular area. Nowadays, we are also having capabilities to link back the 3D GIS based on finding out or doing a spatial query and linking into a temporal domain. So that allows a kind of simulation and modeling. So in this case, we are saying that if any dam breach is going to happen in a particular area, so what may be the different tempo do a query in a specific temporal domain. So let's see that how exactly we are going to use 3D GIS in a specific projects. So generally it starts with the 3 data collections. So 3 data sets collection actually are different platforms are available. So we are having a LiDAR point cloud data sets. It's actually a LiDAR instrument which can be used to scan a specific areas. There's also now the photogrammetry, especially the close range photogrammetry, which can be used to do a large scale constructions of the building. So over here we are seeing area where we are having different photographs, and that has been used to do a construction of 3D point clouds. The 3 data sets or the images can also be collected from the UAVs to get a top views, and that can be used to generate a detail level of DEM data sets that can also be used. So the first step is always starts with a collection of 3 data sets. Then the next step is actually linking that 3 data sets back with the corresponding features which we expect to see in a geographical domain. So for that we need a different footprint which needs to be created, or that may be available from different cadastral map, or it can also be used based on the digitization. So we may be having a high resolution data sets that can be used to create a different footprint, and that can be used as a input for 3D base layer generations. The DEM datasets actually helps us to create a realistic surface, because in the real time we are not going to have a flat surfaces. So it basically allows the creation of the different surface models. So for that we need DAM and DSM layers. So combinations of these two actually helps in creating actual 3D base layers. And this 3D base layer actually helps in linking all the 3D datasets and the corresponding footprint. What we see over here is actually different buildings is being created, and then that can be used, that can be stored in a 3D geospatial datasets. The corresponding attribute of different layers which we can create it from the existing data sets. For example, in a specific we can have a road layers, or it may be having a different utility lining or different land use patterns. So that can be linked with a 3D attributing. Over here 3D attributing basically means that not only the lat long values, but we can also add the JUD values associated with each of those features. So all the 3 data sets, all the 2D GIS data sets gets converted into a 3D GIS data sets, and these two data sets get stored in a common format in 3D geospatial data storage. So this actually creates over here actually we are ending the process of data generation. So over here we are seeing that the data collection process, there's a footprint extractions. Combinations of these two actually helps us to do height extractions from the buildings, and then corresponding models which needs to be which gets created. Based on that, again we can link in different layers, and then we can have a 3D data sets. Later on, these 3 data sets can be used for different purposes. For example, we can use these data sets for visualizations, as we have seen few of the cases earlier, or we can do a 3D analysis, or the 3D GIS analysis can be used to do a further activities. So let's take the few example where we are seeing how the different 3D GIS interaction happens with the corresponding interface. So over here we are seeing different 3D models. So we can do a selections of features and see the different attributes. We can also do a classifications in a real time in a different format. We can also create a fly through of the 3D area or 3D GIS data sets. So this actually helps us to visualize the complete data sets in a different perspective and angles. So it actually helps and gives an idea of the complete 360 view of data sets to have an interactive visualizations. The other part of the 3D GIS is actually a spatial query. So under that we can have analysis like 3D buffer analysis. So what we do is we create the impact or the sphere around a point, and based on that we can see that which all area or attribute area or the different classes of building will get impacted. So over here we are seeing that if a radius or explosion radius is around 50 meters, so the corresponding buildings which will get impacted is being shown in a red colors. That can also be extended to have analysis like in case of different resistance is being provided. So what we are doing is we are bringing the attribute of concretes and the corresponding impact of the area. So all the shadows areas gets will not be affected by the corresponding explosion. So that kind of analysis can be carried out. So this is basically an extension of 3D buffer analysis, and then also including the material properties of surrounding areas. We can carry out a real geometrical properties determinations. For example, the height estimations of a particular building. We can also see find out what exactly is the area, surface area of these buildings, what exactly is the volume of that particular building. So all these can be used for different planning purpose. For example, the surface area can be used to find out, let's say, repainting of this whole building. So the corresponding unit cost can be multiplied with the per unit charges, and we can get a detail of what may be the cost of repainting the specific building. Similarly, there are different applications can be considered based on complete geometrical property determinations. There are also analysis specifically like the view side analysis, very good to identify the number of specific cameras to have a visibility. So that can be dependent upon we want to have a visualization specifically in the ground coverage areas, or we want to have a visibility as a different 3D domain itself. So correspondingly 3D view side analysis tools can be used to do a visualizations in a different cases. So either 3D data sets which gives the different buildings which are completely covered by from a particular locations, or which are not covered by. So over here the green colors are actually showing which is visible from a specific point, and the red colors of the buildings are the area which is falling in the shadow area of a building. There may be also ways to find out what exactly is the ground coverage which is possible. So again, this has a lot of applications specifically in the security domains. There's also a way to find out the terrain analysis. Again, terrain analysis can be used to find out the visibility of the area in a specific domain. Or it can also be used in its applications, for example rain shadow area determination, so that there also we can find out which our area may be having a less rains due to the aspect of the hills. There's also possibility of doing an shadow analysis, which can again be used to identify or quantify the solar potential of each surfaces of the building. So it allows you to get a detail in a temporal domains where we can provide how the sun will illuminate a particular buildings, and 3D GIS can be used. Let's take an example of this case. So over here we are having a specific city planning area, and we are working on a specific zones. So over here we are having an historical data sets of 2005, 2000, and then we are also having a 2010 data sets. Based on the trend data sets, the way the 3D is getting vertically expanded in a city area, we would like to know that how will city will look like in a specific year. And there are few planning criteria, so it means like there will be few restriction of development which will always will be laid out by the different agencies. For example, you're having restriction over here that around the heritage area you cannot have a building more than 30 meters, so that can be put in. So there may not be possibility, there is no possibility of having a high-rise building in a specific buffer zone of a city. So if you consider all those different planning areas or the planning conditions or the rules in land development cases, so we would like to visualize how it will look like in a different scenarios. So this is actually showing the area or activities where in a yellow color is actually it's in the rectangle box is actually showing the area where the high-rise building is expected to come based on the trend, the way the land use has changed in a specific zone. So bringing that how it will look like in 2020, so we'll see that the expected growth in a specific area is showing, and we are seeing that expected changes in a multi-story high-rise building is expected to come in a different locations to accommodate the existing immigration and immigration on both the area in particular cities. There's also a restriction has also been put in. So this actually gives the different few scenarios which can be generated based on the historical input and taking account into the historical change rate, and then also seeing that if those rules and regulations are being built, how the future landscape will look like. Now let's say that instead of having the status quo, we would like to propose a large scale reconstruction. So we are seeing an area where we are having a different different buildings as per the current scenarios, and if you want to suggest that there are how many households are there and correspondingly what are the total populations living in that particular area, if you want to create or come up with a area appropriate basically the appropriate redevelopment plan, so in that cases we need to generate that scenario on how it will look like. So to accommodate those many peoples, we can have different buildings at heights. There may be static plant colonies, and those areas can be changed. So this is actually showing that keeping the landmark place the way it is, and then we can also do a landscaping of that area. Along with that, we can allow a migration of different peoples by redeveloping a specific zone. So this gives the condition or the scenarios where the different residential plannings can be applied. So in this case, we are seeing that 3D GIS is actually helpful in visualizing what kind of future scenario may come in, and how will the basically overall planning or the rules and regulation is going to impact with the proper planned development of a cities, and that such kind of different applications is possible with the help of 3D GIS. So I hope that I am able to give you a glimpse of 3D GIS and its different techniques, different data creation of these data sets, and then how we can use in a specific case studies. Thank you.